Dear 9th class students, we are going to discuss in the chapter lines and angles. Our next topic is angle sum property of a triangle. So what is angle sum property of a triangle? Sum of the three interior angles of a triangle is equal to 180 degrees. This is the statement. So the statement is sum of all interior angles of a triangle equal to 180 degrees. So this is the theorem. So now take triangle. This is A, B, C. Right? Say these are the interior angles. Say angle 1, angle 2, angle 3. These are the interior angles. So now let us start. Given angle 1, angle 2, angle 3 are the interior angles of a triangle ABC. This is given. What is required to prove? Required to prove is angle 1 plus angle 2 plus angle 3 equal to 180 degrees. So the sum of the three interior angles is equal to 180 degrees. Now I am going for construction. What construction I am doing is I am drawing a line parallel to BC through A. So say this line is some xy. So this xy, the line xy is parallel to BC. Okay? So construction through A, through the point A, draw a line xy parallel to BC. This is construction. Now proof. So here the angle is say angle 4 you say, which is here the angle is angle phi you say that. Now I claim that angle 4 is equal angle 2. Why? Because these two lines are parallel and this is transversal. So as we have discussed in the previous class, so when a transversal is intersecting two parallel lines, alternate interior angles are equal. So that's what we begin. So xy is parallel to BC. It is given. It is not given, it is construction. It is construction. And AB is transversal. Therefore, angle 2 is equal angle 4, alternate interior angles. Alternate interior angles. Similarly, angle 3 is equal angle phi with the same reason, alternate interior angles. Okay? Now, add these two equations. Okay, angle 2, on adding these equations, on adding, what you will have? Angle 2 plus angle 3 is equal to angle 4 plus angle phi. I added these two equations. Now add angle 1 on both sides. So if you add angle 1 on both sides, then you will have angle 1 plus angle 2 plus angle 3 equal to angle 1 plus angle 4 plus angle 5. But if you add these three angles, okay, straight angle will be formed. If you add angle 1, angle 4, angle 5, a straight angle will be formed. So angle 1 plus angle 2 plus angle 3 is equal, this is a straight angle. The sum of these three angles is a straight angle. So 180 degrees. So angle 1 plus angle 2 plus angle 3 is 180 degrees. Hence proved. Understood? So now dear students, our next theorem is exterior angle theorem. What is exterior angle theorem? I am not writing statement, but I am reading out the statement. See, if a side of a triangle is produced, then so formed exterior angle is equal to sum of its opposite interior angles. This is the statement. Once again I repeat, you see, if a side of a triangle is produced, then so formed exterior angle is equal to sum of the opposite interior angles. This is popularly known as exterior angle theorem. So now take this triangle, triangle ABC. Right? Now we are producing BC, to some extent D. Okay? Now the exterior angle so formed is angle ACD. This, as per this theorem, this angle ACD is equal sum of its opposite interior angles. So angle A plus angle B, this angle ACD is equal angle A plus angle B. That's what we are supposed to prove. So now given, what is given? Here let us write. Given triangle ABC is such that angle A, angle B, angle C are its interior angles. Next, the side BC, another given information is the side BC is produced to D, up to D. Then what is the exterior angle so formed? Angle ACD. So angle ACD is the exterior angle so formed by producing BC. So what is required to prove? That so formed exterior angle is equal to sum of its opposite interior angles. So angle ACD is equal to angle A plus angle B. This is what we are supposed to prove. Did you understand? So how do we prove this? You see now. So now proof. As just now we have proved that sum of the interior angles in a triangle is 180 degrees. So that is angle sum property of a triangle. Sum of all interior angles of a triangle is equal to 180 degrees. This is angle sum property of a triangle. So angle A plus angle B plus angle C is equal 180 degrees because angle sum property. I am writing with abbreviations angle sum property, but you have to write the complete sentence. Okay. Now angle C plus angle ACD is equal to 180 degrees. Linear pair, they form linear pair. The 180 equal. Then angle A plus angle B plus angle C is equal to angle C plus angle ACD. Now this angle C get cancelled. So angle A plus angle B is equal angle ACD. So that's what we are supposed to prove, hence proved. Understood? Dear students, now we are discussing the new chapter triangles, right? In this chapter we are going to start our discussion with the very basic word triangle. What is triangle definition? A closed plane figure formed by three intersecting lines is known as triangle. Once again I repeat, a closed plane figure formed by three intersecting lines is known as triangle. See, this is a line, this is another line which is intersecting this line, this is another line which is intersecting the two lines. Okay, so these are three intersecting lines. Okay, this is a closed figure formed by these three intersecting lines. So this is called a triangle, and you write like it is triangle ABC. Did you understand? Now here AB, BC, AC are called sides of the triangle, and angle A, angle B, angle C are called angles of the triangle. And as you know that angle A plus angle B plus angle C is equal 180 degrees. So this is about triangle. Coming to next point is congruency of triangles. Congruency of triangles. Criteria of congruency of triangles. So when two triangles are said to be congruent, it is most important. So you can easily say if one triangle covers completely the other triangle, then the two triangles are said to be congruent. One triangle completely covers the other triangle, then the two triangles are said to be congruent. So in mathematically, this is in a general language. I said if you want to say a mathematical definition of congruency, you can say two triangles are congruent if the corresponding angles are equal and the corresponding sides are also equal. So here you see this is triangle ABC. So this is another triangle. This is triangle PQR. See, so in these two triangles, suppose that in triangle ABC and in triangle PQR, suppose angle A is equal to angle P, angle B is equal to angle Q, and angle C is equal to angle R, and AB is equal to PQ, BC is equal to QR, and AC is equal to PR, the corresponding angles are equal and the corresponding sides are equal, okay, then the triangle ABC and triangle PQR are said to be congruent triangles. These are said to be congruent triangles. How you express the congruency using notations? So using notations you express the congruency between the two triangles as triangle ABC is congruent to triangle PQR. And this angle A and angle P, angle B and angle Q, angle C and angle R, these are called corresponding parts of congruent triangles. Similarly, if you come to sides AB and PQ, BC and QR, AC and PR are also the corresponding parts of two congruent triangles. Corresponding parts of two congruent triangles are always equal. So we use an abbreviation CPCT, stands for corresponding parts of congruent triangles. Corresponding parts of congruent triangles. We use the abbreviation CPCT whenever you are equating the corresponding parts of two triangles, if it is known that the two triangles are congruent. So when you are equating the corresponding parts, you should write CPCT. Understood? Now, as far as the congruency of triangles is concerned, we have an axiom. It is popularly known as SAS axiom. Axiom means, you know, it is evidently true, which required no proof at all. So it is SAS axiom for congruency of two triangles. So here I am writing SAS axiom. For congruency of two triangles. So what is that SAS axiom is? In two triangles, if any two corresponding sides are equal, any two pairs of corresponding sides are equal, and angle included between them is also equal, and angle included between them is also equal, then the two triangles are congruent. Understood? Now I'll explain, you see. This is one triangle. Say this is another triangle. I'm trying to explain you the concept of SAS axiom. So this is triangle ABC, this is triangle PQR. Then you take any two pairs of corresponding sides. As per this theorem, any two pairs are equal. You can take this AB PQ as one pair, BC QR as second pair, or AB PQ one pair, AC PR the second pair, or AB PQ one pair, BC QR the another pair. You can choose any two pairs, so there is no restriction at all, but any two pairs of corresponding sides should be equal. So I am choosing now AB PQ to be equal, AC PR to be equal, and angle included between them Here this is a A which is included between these two sides, and this is a angle which is included between these two sides. And suppose if these angles are also equal, then as per this theorem, as per this axiom, these two triangles are congruent. Understood? So here you see, as per SAS axiom, in triangle ABC and in triangle PQR, AB is equal to PQ, angle A is equal to angle P, AC equal to PR. So, two pairs of corresponding sides are equal and angle included between them equal, then triangle ABC is congruent to triangle PQR by SAS axiom. This is not a SAS theorem, it is axiom. Theorem will be proved, axiom is evidently true. Understood? Dear students, now we are going to discuss ASA congruency rule. This is not axiom, this is theorem. So that we are supposed to prove this, of course we will prove it. So first, the statement of the theorem is the two angles and included side of one triangle are equal to the two angles and included side of the second triangle, then the two triangles are congruent. So what is given in this triangle ABC and in this triangle PQR? This angle equal this angle, this angle equal this angle, and the included side of the first angle is BC. Included side means the side including these two angles, which is BC. The side including these two angles, which is QR. BC is equal to QR. So angle B is equal to angle Q, BC is equal to QR, angle C is equal to angle R. Then we are required to prove that triangle ABC is congruent to triangle PQR. So now, proof. So there arise three cases. What are those three cases? In three cases we are going to prove the theorem. That case one is, suppose we consider that AB equal to PQ. We are considering that AB and PQ are equal. So in this case, then in triangle ABC and in triangle PQR, so AB equal to PQ by our assumption, angle B is equal to angle Q, this is given. Are you following? And the BC is equal to QR, it is also given. So here see, side angle side is formed. Therefore, by SAS congruency axiom, you can conclude that triangle ABC is congruent to triangle PQR by SAS congruency axiom. Understood? So now in case 2 we are assuming that AB is greater than PQ. See the diagram. So when AB is greater than PQ, okay, you can find a point on AB, such say that point is some D. You can find a point D on AB so that BD is equal to PQ. So this is possible because AB is greater than PQ. So it is obvious. So let AB is greater than PQ. Therefore, then there exists a point D on AB such that BD is equal to PQ. Obvious. Now let us take these two triangles DBC and PQR. Now in triangle DBC and in triangle PQR, angle B is equal angle Q by given, and DB is equal to PQ, okay, by our assumption. Angle B is equal angle Q is given, and BC is equal QR, again it is given. Therefore triangle DBC is congruent to triangle PQR by SAS axiom. Understood? So the moment the triangle DBC is congruent to triangle PQR, you can say that angle DCB is equal to angle R by CPCT. Did you understand? But angle ACB is equal angle R, it is by given. Therefore angle R equal, so angle DCB is equal angle ACB, where angle ACB is the whole angle, angle DCB is the part angle, where whole angle cannot be a part angle equal to part angle, whole angle cannot be equal to part angle. Therefore a contradiction arised, okay? Therefore a contradiction arised. We considered that AB is greater than PQ, so it is not possible. So AB is equal to PQ finally, because you cannot accept this contradiction. So a contradiction arised. So with this contradiction you can conclude that AB is equal to PQ. Similarly, you can prove when AB is less than PQ. So in all cases, okay. So at the moment AB is equal to PQ, then again what will happen? The triangle ABC is congruent to triangle PQR by SAS axiom. So even similarly, if you proceed further, okay, similarly it can be proved in the case 3, which is even AB less than PQ. In this case also you can establish that triangle ABC is congruent to triangle PQR. So in all cases the theorem is proved. Understood? See, dear students, now some properties of triangles we are discussing, okay? Some properties of triangles. One is isosceles triangle property. So we are going to discuss isosceles triangle property. What is the theorem is? In an isosceles triangle, angles opposite to equal sides are equal. You know what is isosceles triangle? Isosceles triangle means a triangle in which any two sides are equal, then it is isosceles triangle. So this triangle is isosceles triangle, okay? So given triangle ABC is an isosceles triangle such that the two equal sides are AB and AC. So AB is equal to AC. So what we are required to prove is angles opposite to equal sides. So the angle opposite to this equal side is angle C, this equal side is angle B. So angles opposite to equal sides are equal. So we are supposed to prove that angle B is equal to angle C. Now I am going to do a construction that draw a bisector AD angle A. So draw the bisector of AD of angle A. So we are drawing a bisector of angle A, which is AD. Bisector of angle means which divides the angle into two equal halves. So therefore it is very clear that angle BAD is equal angle CAD according to our construction. Now if we go for proof, now in proof what I am doing is I am taking triangle BAD and triangle CAD. So in triangle BAD and in triangle CAD, so angle BAD is equal to angle CAD by construction, and this side equal by given, and it is a common side. So in these two triangles AB is equal AC, it is given. Next, angle BAD is equal to angle CAD, it is by construction, and AD is equal AD, this is a common side. So finally angle side is formed. Therefore triangle ABD is congruent to triangle ACD. Are you following? Triangle ADB is congruent to triangle ADC by SAS congruency axiom. The moment these two triangles are congruent, the corresponding parts are equal. So here triangle ADB is congruent to triangle ADC. We have proved by SAS axiom. See, obvious, no? I shared all the reasons here. So the moment these two triangles are congruent, you can equate the corresponding parts. Therefore angle B is equal to angle C by CPCT. Hence we have proved that isosceles triangle property. Understood? Dear students, now we are discussing the converse of the previous isosceles triangle property. The theorem is, in a triangle, if any two angles are equal, then the sides opposite to equal angles are also equal. So given that in triangle ABC two angles are equal, so angle B is equal angle C, we are required to prove that the sides opposite to equal angles are equal. So we are supposed to prove that AB is equal AC. Now we are drawing a line AD which is the bisector of angle A. So this line AD is the bisector of angle A. This is construction. Now proof. So as far as proof is concerned, now you see this angle equal to this angle by construction, this angle equal to this angle by given, and AD is common side. So two angles, one side. Of course that side is not included between these two angles. So here it is not ASA, it is AAS. Of course AAS is also one of the congruency criterions. So in AAS, the side need not include the two angles. So here you see proof. In triangle ADB and in triangle ADC, are you following? Angle BAD equal to angle CAD, it is by construction. Angle B is equal to angle C, it is given. AD is equal to AD, which is common side. Therefore AAS. So Dear students, please do remember AAS also is also one of the congruency criterions. Therefore, by AAS criteria, you can conclude that triangle ADB is congruent to triangle ADC by AAS criteria. The moment two triangles are congruent, so by CPCT, therefore you can conclude that AB is equal AC by CPCT. Therefore, we have proved the theorem. Okay, this ends the theorem.